The topic of our next session is ChatGPT, no eye rolling. It really doesn't require too much of a setup. I mean, it's inescapable as a topic right now. But I'm really excited to have George Khachatryan. He is the co-founder and CEO of Offerfit here to share a marketer's perspective on what this means to e-commerce and marketing, because I think there are still a lot of unanswered questions about that. He is uniquely qualified to talk about this topic. So he has a PhD in mathematics from Cornell. He built an educational technology company that uses AI to deliver personalized math instruction that's used by more than 1 million students. He spent 4 years at McKinsey helping companies transform their retail, their marketing, and their sales operation. He's here today as the CEO and co-founder of Cofounder. He co-founded this company with this big vision of using AI to automate experimentation and make A/B testing obsolete. So please join me in welcoming to the CommerceNext stage, George Khachatryan.
Thank you for having me. So today we're going to talk about how this recent explosion of AI that we've all witnessed, ChatGPT of course being the prime example, is going to change marketing. And I'm going to try to look ahead about 5 to 10 years and try to paint what I see is probably going to happen to all of our jobs and how those jobs are going to evolve and change. All right, so first of all, what qualifies me to talk about this? So I'm the co-founder of Offerfit. We're an automated experimentation platform. So Offerfit is used to replace manual A/B tests with automated experimentation for lifecycle marketing. We have about 55 employees. We're headquartered in Boston, and we're growing quickly, about 4x annualized. So today we're going to cover 4 topics. First, what caused the current AI explosion, in particular ChatGPT? Second, how is AI transforming business? Third, how will AI solve the biggest challenges in marketing? And finally, what are some examples of successful AI-driven experimentation? So first, let's level the playing field and talk about what is artificial intelligence. The best definition I know of is it's times when computers do things that normally we typically only associate with people being able to do. Cognitive tasks that are the domain of people. One great example is chess. So if you go back in time, even less than 100 years ago, chess was seen as the pinnacle of human reason. It was this pure game of thought and strategy. Of course, only people could play chess. Now today, the best computers play chess much better than the best people who ever lived. So this would be an example of artificial intelligence, even though maybe people don't think of it that way today. Another example is recognizing handwritten digits. There used to be postal centers where people would spend all day sorting mail and recognizing digits. Now, of course, this has been automated, and computers do this just as well as people. And more recently, here we have our friend William Shakespeare, writing. So writing is something that a couple of years ago computers were terrible at, and right now I think we've all seen that they can actually write very well with these large language models like ChatGPT. So people have been dreaming about this since prehistory. Homer wrote about, not even wrote, right, because he didn't write. Homer spoke about robots that would walk around and that would think about things and interact with people. In the 18th century, there was this famous phenomenon called the mechanical Turk. And this was a robot that toured various European cities and would play chess against people and usually would win. And of course, it turned out later there was a dude that was hiding in the box. So this was all a fraud. But it just tells you how this has captured the human imagination for centuries, really. There's this wonderful quote by John McCarthy, who's one of the founders of the field of AI, which is, as soon as it works, no one calls it AI anymore. You can almost sense the frustration that he must have had when he said this, right? Because it's someone who spends his career doing AI. And you can see him sitting there with a chessboard. Chess is a great example, where now if you say, oh, computers are better than people, well, okay, sure, but is that really that impressive? We've become desensitized. But ChatGPT is perhaps the first example where I think that desensitization is taking longer. I think people are still calling this AI, even though it works, and we've probably all used it. So next, let's talk about AI and what exactly it is and isn't. Is AI machine learning? People probably hear both of these terms, and they're vague in a lot of people's minds. So let's take a moment to think about this. And so what I'm going to claim is actually AI, for all practical purposes, is machine learning. They're essentially one and the same. And there's this quote from a conversation I had a few years ago that really stuck with me. I was chatting with a marketer, and she said something like, sometimes you hear about something, and it says it's AI, and then you learn more about it, you look under the hood, and it's just statistics. And that really stuck with me, because it's actually a very powerful phrase, just statistics. So what does that mean? Take a look at this scatter plot. Imagine each point here is a day on which you had a certain advertising spend, and then you recorded how much revenue you booked that day. So this is some historical actual data set. You're going to use classical statistics to plot a line of best fit. That's the line of best fit there. And what that line is it's making a prediction. It's telling you on a new day, if I give you a certain advertising spend that I'm going to have, it'll predict how much revenue do you expect to get that day. So you can think of this classical statistics. This line has learned from your historical data how to predict what your revenue is going to be from your advertising spend. So that's classical statistics. But of course, in real life, you don't always have data that looks so beautifully linear. Sometimes it has a shape that's not a line. Something else fits better to it. So until the 1980s, there was no toolkit for dealing with this. And the reason for that is that if you're doing calculations by pencil and paper, everything has to be a line. Otherwise, you just can't do the calculation. It's too complex. That changed in the 80s. In the 80s, compute started to become available. And throughout the 80s and 90s, there was this huge explosion of research of people taking classical statistics, generalizing it to situations where it's not a line, it's some nonlinear relationship, and using compute to actually build those models. That field is what is called machine learning. So when you hear about machine learning is just statistics generalized to things that are not lines. And if you hear about artificial intelligence, technically people will tell you, well, it's broader than machine learning. Machine learning is this specific toolkit. For all practical purposes, though, artificial intelligence and machine learning are the same thing. Anytime you hear about something that works well that's artificial intelligence, whether it's ChatGPT, driverless cars, recognizing digits, or any of these other things that you hear about, it's machine learning. And what are the types of models that machine learning uses? Well, here are some examples. Decision trees. Of course, you don't just use one decision tree in machine learning. You use a bunch, and you average them in a smart way. But it's just that simple. It's a decision tree. A lot of the most effective machine learning models are just smart ways of using a lot of decision trees. Neural networks. A neural network also, it sounds very mysterious, but it's really just a calculation technique. It's a way to take input data and turn it into a prediction in a way that lets you do very well in situations that are not linear. And finally, support vector machines. We will not go into detail on those today. So here's an example of a decision tree, which is making a prediction. Can someone guess, what do you think this decision tree is predicting? Any takers? Feel free to just shout it out. Titanic, that's right. This is predicting survivorship on the Titanic. And this is actually a very famous data set. A lot of people, when they're first learning machine learning, this is the first data set that they start to play with. And it turns out you can do very well on predicting this by building a bunch of decision trees. This looks at your gender, your age, and how many siblings and spouses you had on board the Titanic to make a prediction on whether you survived or not. You can take a bunch of these decision trees, average them together, and you get a rudimentary machine learning model. And so you might wonder, is ChatGPT the same thing? Or is it different? It's generative AI, right? It's writing. It's not predicting. Actually, it is predicting. ChatGPT is exactly that type of model. It's a large neural network model. And what it does is it predicts the next word, one word at a time. And so, for example, it'll look at, the Titanic was a fill in the blank. Terrible. That's pretty likely. The Titanic was a terrible tragedy. Great is pretty likely, too. It was a great movie. But the Titanic was a giraffe. Well, that's not very likely at all. So it's far more likely to come up with one of the other two words when it's completing that sentence. So then, why is it so good? You might be thinking, if it's that simple, why is it so good? And the reason is this graph. So several years ago, there was a research group at Google that published a paper called Attention is All You Need. And it introduced a type of neural network called the transformer for predicting the next word. And it had this very interesting property, which is captured by this graph. You see the parameters on the x-axis. That's how big that model is. And on the y-axis is the loss, which you can think of as the error rate of that model. And as you can see very predictably, the bigger you make the model, the smaller is the loss. The better it becomes, the more accurate that model becomes. And when people saw this, they started to think, wow, so this means that we can go spend $100 million to train a ginormous model and spend that on compute. And it's not a science fair project. You can actually have pretty good certainty that you're going to produce something that is really, really accurate. And that's why they're called large language models. And that's why ChatGPT, as well as some of these other models like Bard, are so extremely good. So now I think we've answered this first question of why is it that we've seen this explosion in AI? It's because people chanced upon these types of models now that have this power law or this scaling law. They know they can make them bigger and it'll work better. So now let's turn to marketing. What is the marketing dream, and how are we going to see AI influence that dream? So this is almost a cliche at this point, right? I think what we all want is the right message with the right product, the right incentive, through the right channels, with the right timing, with the right frequency for every individual based on all the first-party data that we have about them. What are the things that stand between us and that? I think pretty much everybody here would say we're not quite at that ideal yet. And so I think there's three main bottlenecks. There's three main things that stand in the way. First is data integration. So data comes in different formats and different systems, and getting it all to talk across these different formats is actually quite hard. The second is content authorship. So it just takes time. You need a large library of content if you're going to be personalizing to each individual. And it takes a lot of time to be able to create that content. Marketers just don't have that capacity. And the final bottleneck is what I call the experimentation bottleneck. A/B testing is effective, but it's extremely slow. And that's the only way to discover for each customer what is that best action to take. So these are the three things today that are standing in the way. And it's because these are mundane tasks. Doing each of these, it may not be difficult, but doing enough of it actually just takes way more time than human beings can possibly have. And so let's go through them one by one right now and see how AI is going to change these fundamentally in the next 10 years. Let's start with that first task, which is data integration. This isn't talked about as much as the writing skills of models, but actually these language models are extremely good at working with data and writing code. And so here you see I prompted ChatGPT and I gave it a table of email data, clicks, opens, and sends. And it's in a certain format called long format, where you have one line for each event. And I told it, can you write some Python code to transform it into wide format, where it's more aggregated? And instantly it produces beautiful, concise Python code, and it even shows me what the output will look like. Already today, people are building products that are going to do this for marketers across all of the different data systems that you have. So fast forward 5 years from now, it's going to be vastly easier to connect your systems and get them to all talk to each other in a smooth way. So that data integration bottleneck, which has already been chipped away at so much by data warehouses and CDPs, is going to be even further removed in the next 5 years. Content bottleneck. So here I asked ChatGPT to write a poem. So as you know, Veronica, Alan, and Scott are the three founders of CommerceNext. And there's also a Cavalier King Charles Spaniel that Veronica has named Lulu, who is given a co-founder credit. And so here's what it wrote. In bustling halls where marketers convene, CommerceNext, the conference, reigns supreme. Veronica, Scott, Alan, Lulu too, lead the pack with e-commerce in view. Ideas flow like a digital stream as marketers dream their e-commerce scheme. Lulu barks insights, oh what a sight, a dog's perspective bringing delight. I think it's fair to say very few of us in this room could write a poem that good. And so you can imagine that now tools are going to be built that are going to make it possible to build large libraries of email and website content, et cetera, in a way that's on voice, brand appropriate, and then provides that library that you can use to help approach that dream that we talked about. So how about automated experimentation? And this is really where I spend all of my time, and this is Offerfit's focus area. It's removing the pain of A/B testing. And so here's how an automated experimentation platform like Offerfit replaces mundane A/B testing with AI. It sits between your data systems and your execution platforms. So once a day, you can imagine data being pushed from your warehouse or your customer data platform into Offerfit. And then Offerfit makes recommendations for each individual customer. And these are really decisions, saying, for this person, send them this email with this copy, subject line, call to action. For that person, send them a text message. And you know what? Give them 5% off. For this other person, do nothing today. And this is a daily continuous process. So this loop gets closed, and that's how the models learn. Because the model is experimenting over time, and every time it makes a decision, it then sees later on, how did that decision turn out? Did it work out well or did it not work out well? Was it a purchase? What was the value of that purchase? And it gets better and better over time at matching each individual based on their data with what's best for that person, without the need for any kind of manual A/B testing. It's all fully automated. And so what are some examples of this? One of our customers is Brinks Home, which is a top 3 home security company. And this work actually that we did together was featured in Harvard Business Review last year. So Brinks has contracts. You're on a home security contract, and then it's going to come up for expiration. and they're going to reach out to you with an offer to extend your contract. And they're going to offer you something. And there's a lot of decisions that they need to make. First, what channel? Do they email you, or do they actually pick up the phone and call you? What time of day and what day of the week do they reach out to maximize the likelihood of connecting with you? If it's an email, what's the subject line? What's the creative? And then last but not least, what is it that they offer you? Who needs a discount to convert versus somebody who needs a free doorbell camera versus someone who will convert with no discount? They're ready to convert anyways. They're willing to accept a rate lock. And so Brinks has about 1 million customers, and now they're able to individually for each customer have a unique journey that takes into account all of that person's data and makes an optimal decision across all of these dimensions for that person every single week that they're communicating with them. And you can see this can drive quite significant results because it's like having a team of 100 people constantly doing A/B testing. They started out with their Offerfit group performing on par with the control group. This was a pilot they did 2 years ago. After a week and a half, the performance started to exceed the control group that was the business as usual. And by the end of their pilot, it was over 200% lift in the financial performance of the campaign. And since then, in the intervening 2 years, it's continued learning, and now it's actually up to 400%. Another example is a leading restaurant chain, which makes delicious fried chicken. And so in this case, it's an email campaign in order to maximize repurchase. And so here, the individualized decisions to make are things like time of day. Very important if it's a going to eat decision. Subject line, frequency. How often do you email people? If you over-email, then you run the risk of getting them to unsubscribe. Whereas if you under-email, you're missing out on revenue. And there's a sweet spot, and that sweet spot is different for each person. So being able to detect for each individual, based on what you know, what's the optimal frequency, can yield quite a bit of uplift. And then finally, what do you talk about? Is it a chicken sandwich, or is it a delicious bucket of fried chicken? And so you can see they saw a 10% increase just from informational emails, not even using promotions in the repurchase frequency. So let's summarize. What are some of the things that we covered today? First of all, for all practical purposes, AI is the same thing as machine learning. Technically, AI is defined to be broader, but in practice, every time you hear something that's AI, whether it's ChatGPT, driverless cars, the technology that makes that possible is machine learning. And machine learning is just statistics. But statistics is not just statistics. Statistics is kind of amazing. These tools that initially were used for very, very pedestrian purposes and just plotting these lines, it turns out when you generalize them and you can go beyond the line using the power of compute, you suddenly have these things that perform incredibly well at tasks we could never imagine that a machine could do. What's the cause of the current AI craze? Well, it's this model that we talked about, the transformer, and this broader idea that for certain types of machine learning models, people discovered that there's this very predictable relationship between the size of the model and its performance. And that's what allowed people to start building large language models, justifying $100 million investments in compute in order to achieve these unprecedented levels of performance by these models. Next, in the next decade, AI will tackle all 3 major marketing bottlenecks. There are these 3 things that stand between us as marketers and the dream. It is the data integration problem, it's the content authorship problem, and it's the experimentation problem. Those are the 3 bottlenecks that are mundane tasks that make it so hard for us to achieve that dream of personalization. And now the technology is here. And different technologies, but for all 3 of these are going to come together. And 10 years from now, we're going to see just a radically easier workflow for marketers, where those mundane tasks across all 3 of those are going to be automated for us. And then finally, just as one example that we dove in on is automated experimentation. In that case, we're just seeing really large improvements at a lot of companies, sometimes even more than 200% performance improvements by replacing A/B testing with AI-driven experimentation. Just as one more data point where for certain types of tasks, AI really is exceeding what's possible to do as human beings. So if you'd like to learn more about Offerfit, there's a couple of ways you can do that. We have an anti-mascot, Slowpoke the A/B testing snail. Slowpoke used to A/B test everything. It took forever. Slowpoke did not want to end up as escargot, got on the automated experimentation bandwagon, and so that's the story of Slowpoke. If you're into snails, you can play blackjack with Slowpoke at booth 120. If you're not into snails but you enjoy reading, we also have a white paper about the 3 bottlenecks if you'd like to read in more detail exactly how we think about those and how we see the future of AI impacting those bottlenecks. You can download it at go.offerfit.ai/3bottlenecks or pick up a printed copy at our booth. thank you for having me here, and I hope you have a wonderful conference.